sketching parabolas, and to sketch parabolas you need two steps. First step is to find the turning point by using completing a square, and the next step is to find the x and y intercepts. Alright, let's have a look at this example. So this is the format we have to put it. That's the format we need. Alright, so the h and k are both turning points. So if we have this, which is a parabola quadratic function, so I want to sketch this, and this is the completing a square formula, which is x minus b. So the b value is -8. So by having that, that gives us 4. And the c value is 12. And the b squared would be, half b squared would be 16. And that gives us our turning point. So once I have my turning point, the next thing is to find out the x-intercept and the y-intercept. Alright, our function was so to find the x-intercept, when x is 0, you find the x-intercept. So if I substitute 0 there, so that gives us 16 minus 4, that's 12. And when y equals to 0, so we find an x-intercept. And I zero that. And take the 4 the other side. Much easier if we rearrange it. So that x minus 4 is the square root of 4, plus or minus. Taking the 4 the other side, that gives us 2. So the x, so the x-intercept is 2 and 6. So that is where the graph sits on the x-axis. Let us label. So we have enough information to label our graph. So to do so, let's get right. Just going to quickly give it a good label. Let's start here. So if I get my up there, all right, we have our intercept. So the next thing is our turning point was 4 and -4. So those are the turning points. And it's somewhere there. So if I use that, so label the turning points, the intercept, so that was my y-intercept and my x-intercept. So if I go somewhere there and there, it's much easier to use dots, and it's much easier to graph the function. So this is going to be my turning point. Under there, -4, somewhere there. Oops, where the 2. So if I put my -4 a little bit up to make it more in line with this, if I put -4 there, and I can start from the left side or the right side, and I just have to make sure that my function is continuous function, and I follow. Let's just miss that. But if I start this side here, yeah, try to make it smooth. That's my x. That's my y, and the coordinates for the x-intercept, for the y-intercept is 12, 0, 12, and that is 2, 0, and that is 6, 0, and that's my turning point, which is 4, 4, negative 4. All right, let's look at another example when we have an going to have another example and we have only two terms, so something similar to this. How do we sketch that? All right, we can still use our completing square, and what we could do this one here is we could actually get the x-intercept and the y-intercept. Well, basically this one here has been shifted because your b value will be 0, and this whole graph has been shifted 2 units down. So that means it is going to be on the y-axis. So this has been shifted down, and even if we use the completing square, it's not going to be that much of a beneficial because the b value is 0. So that means the original graph has been shifted. The only thing I need to find out is the x-intercept. The y-intercept will be negative 2. When x is 0, my y-intercept is negative 2. And my x-intercept will be square root of 2 plus or minus. So that means my function will be something similar to this. And I label the square root of 2, leave it in a third form, and that is my negative intercept. And that's it for that one. And how about if you have got a coefficient in front of the x squared? So that is, we could use another different way to do that. So let's have a look at another example on that. So that we could use the quadratic formula, and so let's use the quadratic formula. Another scenario where we have a coefficient in front of the x squared. All right, we want to use the quadratic formula and the turning point method. And what is the turning point method? So let's say if I want to find out the value of x at the turning point, that is going to be negative b over 2a, whereby, let's have a look at an example to make it more sense. So this time, that's what we have. And my a value is 2. B value is 4, and the C value is negative 3. And we know that the x coordinate at the turning point is negative. This is how we find it, negative b over 2a. And once we find the x value at the turning point, we can sub it in back into the original function, which is, this is my original function, to find the y value at the turning point. So that's going to be negative 4b over 2, which is negative 1. Sub it in back to the original function, which is 2. So that gives me negative 5. So my turning point coordinates are negative 1 and negative 5. So once I have those, the next thing is to find the x-intercept and the y-intercept. And let's get more space. So the x-intercept, so my function was, so 2x squared plus 4x minus 3. So if I put 0 there, so to find the y-intercept, so that's going to be -3. So to find the x-intercept, we could use the quadratic formula to find the x-intercepts. So which is, this is the quadratic formula. And we know all our the variables, the values of the variables, so that gives us so that gives me -4 plus or minus, that's 16 plus 24, that's 40 over 4. Then I could use the third, so my x-intercept will be -4 plus or minus 2 square root 10. Yeah, we could simplify from there, but we're not gonna do that. Just gonna leave it as it is. So if I and we know the y-intercept was -3, the x-intercept was, that's the x-intercept, so positive. So it's going to be, well, it's going to go somewhere there. So it's going to be more of that. So if I label my intercepts, so that's going to be, that's -5, it's somewhere there. Let's say that's -1, I think that's what it was, -1, and that is going to be -4. Let's get more space. Comma 0, so that's the intercept. So the turning point there is -1, -5, and this is my positive side over 4, and this is my y-intercept, so that's going to be 0. The x value is 0 and the y value is -3, and in this case here my y value is 0 at the x-intercept. And that's it. So we just have to make sure that we label everything that's required of us, the x-intercept, the y-intercept, and the turning point. So again, this was when you have got a coefficient, you could use the turning point method. And as I've, we got the turning point, the quadratic formula to find the x-intercepts. And also to find the turning point, this is what you have to use. Turning point, value of x at the turning point. X value at the turning point. Alright, and that's it. That's how the graph will look like.